The second thing we did was to look at hydrology, or surface water supply and irrigation. So we did a spatial evaluation of irrigation system types, in which the dominant irrigation systems were estimated for each irrigation or water supply district, and found that the majority of these districts are predominantly using surface and gravity irrigation still, but specialty crops themselves may not reflect that proportion. So in other words, there may be more low volume irrigation used on specialty crops when you compare that proportion to crops as a whole. We also looked at changes in irrigation systems in the last 25 years and found that probably about 20% of the land area in the SACOG region has changed from surface irrigation methods to low-flow irrigation methods in the last 25 years. Estimated applied water for each specialty crop was done within the SACOG region using the 2014 crop map or land use layer from DWR. And so that was calculated for each primary irrigation type. Applied water, of course, depends on both the crop's water requirement and the irrigation efficiency of irrigation systems. So we looked at crops and, of course, their predominant irrigation system types to determine applied water for each crop. We did look at typical yield values for each specialty crop based on CDFA statewide production statistics, but there's actually little research to date on the impact of increasing applied water. And that is what the studies that University of California is doing now, for example, are intended to achieve, is to figure out, well, what happens if we irrigate these crops more than they're used to, and how does that impact yield? So surface water availability was reviewed for irrigation districts as well within the SACOG region, especially those areas with specialty crops. And this information was obtained through reviewing agricultural water management plans. But for some districts, only qualitative information on water rights was available, and it didn't really tell the whole story. But as you'll see later on in the presentation, we did look at that in more detail in the areas, the specific kind of targeted areas that we were interested in the region, where we thought that groundwater recharge was the most suited. So this map shows you the irrigation method in the SACOG region. Now this layer was developed, or is currently being developed by LandIQ. It's not complete. We think it's about 85% accurate. There is no statewide data source for this information. And I'll just explain this legend a little bit. The blue area shows gravity irrigation. The turquoise or lighter blue area shows sprinkler, and the green areas are low volume. And of course, in that kind of lighter yellowy tan color is non-irrigated. But the bottom four categories on the legend, I'll just explain those so you know what they mean. G stands for gravity, and LV stands for low volume, and S is for sprinkler. So when you see the orange area, for example, that says 50G/50LV, that means that we estimate that about 50% of that area is on gravity and 50% is on low volume. So if that said 80-30, then those proportions would be respectively 80% and 30%. On the very bottom, you can see that very light tan color. It says 33 gravity, 33% sprinkler, and 33 low volume. So in that case, we estimate that there's about an equal amount on each of those irrigation types.